Good afternoon, everyone. So, my name is Santosh Kumar, and I will be taking today's class.
Good afternoon, sir.
Afternoon, sir.
Good afternoon, sir.
Good afternoon, sir.
Good afternoon, sir.
Okay, so you can say this is 24th January. So, can you see the screen?
Yes, sir.
Yes, sir.
Okay. Okay, so you all are what? BTech second year. Which branch?
CSIT, sir.
CSIT, sir.
Okay, CSIT. Okay, so I think in the last class you were doing sampling distribution. So, sampling distribution is going. So, I will continue. So, I have to teach. Okay, so I will continue the sampling distribution where you stopped in last class. So first, I will see two things. One is chi-square distribution. First, what is chi-square distribution? Okay, chi-square distribution, and second thing, t distribution. And I hope you already know standard normal because these will be used here. Standard normal and a chi-square distribution is t distribution, a standard normal distribution, or you can say standard normal random variable. So every random variable has a distribution. So standard normal is it is a special case of normal distribution. Okay. So in sampling, these three are important. So the notation we usually use. Okay. So this is chi-square n. Here we write t n. So it's n degree of freedom, and this is we mostly write n01. Standard normal. So we write this is a notation. So first we'll define. Okay. If a random variable has chi-square distribution, so what is meaning of that? So what is the PDF in that case? So first let us define chi-square distribution. So do you know anyone know about chi-square distribution? Would you like to tell something? You know? Okay, no one knows, I think. So okay, let us write. So it is like let a random variable so how to define so you know random variable are of mainly two types, discrete and continuous. So this will be a continuous random variable. So let a continuous random variable okay. So usually we define write x, so we write x. Let a continuous random variable x has chi-square distribution. Okay, chi-square distribution with n degree of freedom. So I'm writing definition. Okay, so I'm just defining. So let a continuous random variable x has chi-square distribution with n degree of freedom. N degree of freedom. So sometimes in short we write df. Df means degree of freedom. Then its density function is So the density function we write. So in short, density function means PDF. So we call it PDF. In short, if you write, so we call it PDF also. Probability density function. So what is a PDF? So we write fx, variable is x. So that is 1 upon gamma n by 2, 2 raised to power n by 2, and x raised to power n by 2 minus 1, and e raised to power minus x by 2, where x is positive, okay. So this is the PDF. You can remember this PDF by, if you know, so this you can remember. So chi-square distribution is a special case of gamma distribution. So okay, let us relate with the gamma. So first, can anyone tell me what is the PDF of gamma distribution, because you have already done it, gamma distribution. So anyone please tell me the PDF of gamma distribution. You can look into your notebook, you can see into book. Please tell. So what is PDF of gamma distribution? So usually notation we write G and somewhere full gamma, and parameters here are alpha and beta. Let us write in terms of alpha beta. Sometimes you will also see lambda and alpha, or maybe some other parameters, but here I'm using alpha beta. So anyone please tell me the PDF of gamma distribution. Yes, you can try, anyone can try, or otherwise I have to ask one by one to everyone. Look in the class notes, if you have any, you look into class notes, check what is gamma distribution, then what is their PDF. So no one knows. Okay, let me start from the end. Yes, Vivek. So I will mark you absent. If you are not here, then I will mark you absent. Yes, Vaisali. Soumya Ranjan. Soumya Kant. Subham. No one knows. So how it can be? I have to inform the teacher. So who is teaching? Apratim or Chiranjeevi sir? I think Apratim.
Somebody ticket my
I'm not able to listen you. 1 minute. Your voice is not clear. I think maybe internet problem from my side, but I don't know. 1 minute. It is not okay. So I have already. Yeah. Yes, I think who were trying to say. Ritik, you were trying. Yeah, you can try again. So if you tell wrong answer, no problem. But at least you try. So what is PDF of gamma? Yes. I have given you the freedom to use notebook book, but you have to tell. You can see your class notes. Obviously the teacher must have taught you.
Alpha I tau I tau of alpha.
Okay, so you are telling, I think, 1 upon gamma alpha beta raised to power alpha. Yes. You can see,
Yes,
you can relate from here
sir.
also. Yes. X raised to power alpha minus 1 e raised to power minus x upon beta. Okay. X is positive. Okay, okay. Yeah, thank you. So this is the PDF, and now you relate it. So gamma is a general case and chi-square is a particular case. So here, now you compare both PDF, and what do you see? So in case of gamma, okay, alpha you'll take, so check here, alpha here is n by 2. So alpha you'll take n by 2, and in place of beta here is 2. So n by 2 comma 2. Okay, so this gamma alpha beta, so alpha is replaced by n by 2 and beta is replaced by 2. Then this distribution is equivalent to chi-square n. So chi-square n, okay, this is have the same distribution like gamma n by 2 comma 2. So this is a special case. Okay, so remark you can write that chi-square n is a gamma distribution with alpha at n by 2 and beta as 2, and PDF is this. Okay, so this is chi-square distribution. Now in case of chi-square distribution, so if x has a distribution chi-square n, then you can remember mean of x is n and variance of x is 2n. Okay, this you can remember. And now so if you draw the graph of the, suppose this chi-square distribution, the graph will look like this, something like this. Okay, and so this is x, you can say. Okay, and here is the PDF. So it will go beyond that electronic like this. Okay, like this maybe. Okay, roughly this way. Okay, so now I will define t distribution. Okay, this is about gamma. So what you can remember, those who want to note down, you can note down. This is a PDF of gamma, and mean is n, variance is 2n, and the graph is like this. Shape of the PDF is like this. So those who want, you can note it down. You can note it down. I started from here. Okay, so this is about chi-square. Now I will define t distribution. So now we have t distribution. Okay, So what is t distribution? So if I define, so in a simple way, let uh, a continuous random variable x, so I'm writing in terms of x only, a continuous random variable x, or you may write in terms of t also if you want. Okay, if you want to write in t, you can write t also. So a continuous random variable t has t distribution with n degree of freedom, if the PDF is, yeah, then, right, this is definition. So then the density function, so the density function, which we call in short PDF, okay, so is fx of t. So not x, I have taken t, so random I have taken capital T. If you want, we may take x also, so like I have taken t. If you want, if you are comfortable, so mostly we write random variable in as x, so I'm writing in x only now. So x has t distribution with n degree of freedom if PDF is like this. So PDF will look like gamma n plus 1 upon 2 upon gamma n by 2 into root under pi n and 1 plus x square by 2, no, x square by n, and raised to power minus n plus 1 upon 2. Okay, and what is the value of x? So x can be any real number here. So this is a PDF of t distribution with n degree of freedom. Okay, now so what is, so how we write? So notation is like this. So we write, suppose x has this t distribution with n degree of freedom. So tn we write. Sometimes you directly write tn like that, or may write like that. So I write tn. So expectation of x will be 0. Okay, for n should be more than 1. Okay, and otherwise not defined. Okay, and variance of x, so variance will be n upon n minus 2 for n should be more than 2. Okay, and not defined otherwise. Okay, so this is a mean and variance. So we write x has distribution t with n degree of freedom, then mean and variance are this. So this is about t distribution. Okay, now we'll discuss the properties. So especially in sampling, there are three distributions: chi-square, t, and standard normal. So standard normal you have already seen. So I will ask you. So you can look your notebook, book, or if you already know, then you can tell. So what is a standard normal random variable or a standard normal distribution? Standard normal distribution. Yes. So anyone tell me what is a standard normal distribution? Anyone? Anyone can try. Okay. So you don't need to hesitate. You can tell wrong answer. I would not say anything. But you have to try. हाँ जी, संदीप, साहिल, साहिल, ऋतिक, राहुल, प्रणव, नंदन, मोहित, मनीष, काजल, हिमांशु, गौरव, देव, दीपक, विपुल, आयुषी, अश्वनी, अपर्णा, अनीसा, अमर, अमर, अमन, अमन, Avilas. What are all these guys? Yeah, tell quickly. Anyone can try. So you know this word already, right? Standard normal distribution, you know already. Or is there anyone who say you have not seen this word earlier? Anyone who have not seen this word earlier? Standard normal random variable or a standard normal distribution.
By mu
Mm-hmm.
root by e power minus 1 by 2 x mu times mu by 7 whole square.
Okay, Asmani, I think you are telling right, but actually your voice is breaking, so I could not hear correctly. But could you try it? What about other?
This mean will be 0 and standard with blue
Yes,
in
right,
our distribution.
right. Achha, tell me one thing. My voice is also breaking to you. Like I'm not able to hear any one of you.
No,
है
sir.
ना? So okay, it is fine
No,
from my side. Good. Okay, okay. So I will tell you. So a continuous random variable. I think both of you, है ना, tried, and I think your answer is correct, but I could not hear clearly. So a continuous random variable. A continuous random variable. So its notation is z especially. You may write x also, doesn't matter, but its distribution is we write z. A continuous random variable z has standard normal distribution. Okay, a continuous random variable z has standard normal distribution. Then, so the PDF is like fx of z. I'm right. Okay, so not x here. X here I will write z. So f0 is 1 by root 2 pi sigma is 1 e raised to power minus half x minus mu. So z minus mu is 0 to 1, so it will be z square. Okay, and z can be any real number, so minus infinity plus infinity. So is it any doubt in that? Okay, so how we write? So we write it like this is a special case of normal distribution. Okay, so standard normal is a special case of normal. So we usually write it like z has distribution normal 0 1. Okay, this is notation. So this z has distribution normal 0 1, and expectation of z is 0, variance of, sorry, not x. Okay, variance of z is 1. Okay, so distribution. Oh, so this I have not told you. T's distribution will look like what? Okay, so okay, I will come to T, but now it's a standard normal. So I will tell you the standard normal look like this. So this is origin. So this is symmetric about origin. Like this. Okay. So it will look like this. Standard normal. Okay. And T distribution will look like So this is also similar, but you may feel like so. This T distribution will look uh, something like this you can say. So when your n will increase, it will tend toward standard normal, okay, like this. So this was for T, okay, this is chi-square. So this was chi-square, and this is T distribution, and this is standard normal, okay. This is standard normal. Standard normal. Now, so I especially defined chi-square, T, and standard normal. So I also told you like mean variance in all the three cases. I also tried to show you the PDF and a shape of the PDF in all three cases. And normal is a particular case of standard normal is a particular case of normal. So standard normal, this is a particular case of normal. So like if I define normal for you, so like we say x has distribution normal mu sigma square. This is general, okay. So its PDF is like fx of x 1 by root 2 pi sigma outside, okay, or inside square root if you write, so you can write sigma square inside 1 by root 2 pi sigma square e raised to power minus half x minus mu upon sigma whole square. X can be any real number. So this is actually general case when mu is 0. So when mu is 0 and sigma is 1, then it becomes standard normal, okay. So in case of normal, mean is mu and variance is sigma square, okay. Now we'll relate all three. So we'll relate standard normal, chi-square, and T distribution. So what is relation between all three? Okay, so before that, these two things, like x bar and s square. So anyone tell me what is the meaning of x bar? So if I say suppose let x1, x2, xn be random samples, okay, random sample, okay. So now tell me in case of x1, x2, xn, what is the meaning of x bar and what is the meaning of s square? So tell me.
Sir, x bar is the mean deviation and s square is the standard deviation.
X bar is not mean deviation. X bar is a mean, sample mean we call it.
Sample mean, yes sir.
Yes, sample mean, and we call it sample variance. So my question to you is, what is x bar? What is meaning of x bar in terms of x1, x2, xn? If you have this quantity, yes.
Sum of all average.
Yes, so you are trying, I think, average of sum. Like average mean is also average.
Yes sir.
This is x bar, 1 upon n summation xi. And what is meaning of s square? So mathematically, what is s square? What is s square? Anyone can try.
The summation of xi minus x bar whole square divided by n minus 1.
Yes, correct. So 1 upon n minus 1 summation xi minus x bar whole square I from 1 to n. Good. So now because when we will be writing the properties, so we will use these notations also. So you should know what is this. Okay. So now I will write the theorem. So theorem is result, okay. So the one theorem is, so one you have seen like chi-square, this you have already seen that chi-square is nothing but 1 minute. Okay, theorem you have seen that chi square n is just special case of gamma. So it was gamma, alpha was n by 2, beta is 2. Okay, next theorem if I write, theorem 1, theorem 2 if I write. So one thing you have seen. And next, if I relate, there is a theorem, so if I write, if S square is sample variance of a random sample okay, so if S square is a sample variance of a random sample of size n taken from a normal population. So normal population means the population has distribution normal. So normal population having variance, so having variance sigma square. Okay, then so check. So S square is a sample variance. So S square is sample variance of a random sample of size n taken from a normal population. So population you know, and sample you know. The sample is taken from population. So then result is n minus 1 S square upon sigma square. Okay, if you derive it, so this will have distribution chi square n minus 1. Okay, so this statistics, so this is a statistics. So statistics is a function of random variables that is free of parameters. So in left side you will not see any parameter. Parameter means unknown variable or unknown quantity. Okay, like lambda you use, alpha, beta, lambda, these things we use in PDF. So n minus 1 S square upon sigma square will have distribution chi square n minus 1. So if you derive it, simplify this, so what will happen? Suppose you simplify it. So this will convert into, so okay, let me simplify. So n minus 1 S square upon sigma square. So what do you do? First let me remove 1 by sigma square, then you write n minus 1, so it is into, and then I write S square. So S square is what? S square we know, because we have already written 1 upon n minus 1 summation xi minus x bar whole square. Okay, so after simplification what happened? N minus 1 n minus 1 cancelled. So if you write it carefully, the summation xi minus x bar upon sigma whole square I from 1 to n. Okay, so this n minus 1 S square upon sigma square, nothing but this. So we can rewrite this quantity as, so writing n minus 1 S square upon sigma square is same as summation xi minus x bar upon sigma whole square I from 1 to n. This has distribution chi square with n minus 1 degree of freedom. Okay, this is the result. So this statistics, so you may name this, like you may write T1, T2 something. So this quantity has distribution chi square with n minus 1 degree of freedom. Proof it not here, so it is out of scope of your syllabus. So proof is not given here, hai na? When you see it at higher level, you will see proof there, but not at your level. So just you have to remember this result and you have to apply it. Okay. So now I will write the remark also. So you can notice something. I have used x bar. So x bar is called sample mean, and x bar we use when mu is unknown. So you remember in case of normal mu sigma square. So what we are writing? So just I have written previous result was nothing but summation xi minus x bar upon sigma whole square. That was here. Just I'm writing same this quantity again. And I from 1 to n, this has distribution chi square n minus 1. So they want to tell you that instead of mean we have taken x bar. But what if we write, so now you check, second point I'm writing, what if we write xi minus mu upon sigma whole square I from 1 to n. Okay, so here what I want to tell, in this quantity what happened, mu is unknown, so that's why I have used mu is unknown, that's why we have used x bar here. Okay, but sigma is known, sigma is known, it is a fixed constant, it will be a fixed constant here. In this quantity if you see, so both mu and sigma are known, because we have used both quantity hai na? So we are saying it as statistics, so it will not involve unknown parameter by definition of a statistics or estimator. So currently, so my question to you is, what is distribution of this quantity? Can anyone tell? So this you must have seen in case of normal, or earlier when you were doing sample, when you were doing distributions, continuous distributions. So you try. So second point, first distribution is chi square n minus 1, xi minus mu upon sigma whole square. Just x bar is replaced by mu here. So here mu was unknown, that's why x bar was estimated value of mu. In second point, mu is known, sigma is also known. So now what will be distribution of xi minus mu upon sigma whole square, summation I from 1 to n? Anyone can try. All of you must try. So no one has idea? Okay, I will give you a hint. I will not write direct this result, I will give you a hint. So suppose if I tell you xi has distribution normal mu sigma square, then can anyone tell me xi minus mu upon sigma will have what distribution? Can anyone tell me? Or not xi, so you remove I, just x. So x is normal mu sigma square, so x minus mu upon sigma will have what distribution? Okay, one hint I will give, this is z, nothing but z. So z is defined like this. If you convert normal to standard normal, so this is like that. Now I have given you answer, so now you can tell. So what is distribution of this quantity z? Z is notation for what? Mainly yes, am I audible? So I'm asking you, what is x minus mu upon sigma? अरे someone tell me what is z? तुम लोग इतने बेवकूफ़ हो गया? तो यहाँ मैंने z लिखा नहीं है, देखो यहाँ पे, यहाँ z क्या है? What is z? सब बेवकूफ़ लोग हैं क्या यहाँ पे? See here, what is z? And you have seen this already. It is not like I am teaching this. This is part of last chapter, standard normal. So what is z here?
Random variable.
Standard normal random variable. This is normal 0 1 we call. So here I am telling you, like x is normal mu sigma square. So what will be distribution of x minus mu upon sigma? So this will be normal 0 1, standard normal. We call it a standard normal distribution. Okay, so this quantity will have x minus mu upon sigma will have a standard normal distribution. So this, if I call xi is normal 0 normal mu sigma square, so xi minus mu upon sigma will have normal 0 1. And like if I ask you, so what is distribution of z square? Z square means xi minus mu upon sigma whole square. So do you know this result? What is the square of the standard normal random variable? Have you seen it? I think you have not, that's why it is problem. Okay, so this will be chi-square 1. Okay, so standard normal random variable will have distribution chi-square 1. Okay, and now there is more properties. So if you write summation xi minus mu upon sigma whole square I from 1 to n. So like something if you don't know, you can tell I don't know, or sir has not taught you, or ma'am has not taught you. So you may tell directly. Then I can tell from the scratch. So like the previous thing I assume you know, like you are at the 8th chapter. So I assume that first 7 chapter you know already. I think 8 or 9. Okay, so xi minus mu upon sigma whole square. This, so I'm adding it. So like x1 minus mu upon sigma whole square plus x2 minus mu upon sigma whole square, like that. So chi-square 1 plus chi-square 1 is chi-square 2. So this will give you at the end chi-square n. So answer for the second point is chi-square n. So look point 1 and 2 carefully. When mu is unknown, so when you use x bar in place of mu, it is chi-square n minus 1. So 1 degree of freedom is less. And in second point, when we have mu xi minus mu upon sigma whole square summation I from 1 to n, so that distribution is chi-square with n degree of freedom. Okay, so this was related to this result. Okay, chi-square. So n minus 1 s square upon sigma square will have distribution chi-square n minus 1. This was one theorem. So next I will write. So next result we have, we call it theorem 3. So it will be what? If z, we usually write normal 0 1. So z is a standard normal random variable. Okay, and let me call it t is, or call it y. So y is chi-square n. Suppose I take name y is a random variable having distribution chi-square n. So then in case of z upon root under y upon n, okay, or you may write, so we are talking about normal 0 1 random variable, and here is chi-square n upon n, chi-square n upon n, here inside bracket is y upon n, this is y upon n, so chi-square n upon n, and this will have distribution tn, t distribution with n degree of freedom. So normal, standard normal in the numerator, and denominator is square root of chi-square n upon n. So that is the t distribution with n degree of freedom. Okay, so these are results. Now, so as I told you, like x is normal mu sigma square. So x minus mu. So I will again ask those who remember. So x minus mu upon sigma will have what distribution? Can anyone remember? This will have what distribution? Actually, this is just recalling, not theorem. Theorem I'll write later on. Look here, second point. You forgot so easily.
Normal distribution.
Normal
Sir.
0 1.
distribution.
Yes, normal 0 1. So it is normal 0 1. And now I'm writing theorem now. So we call it Z. Okay? So okay, first let me write the statement. Statement is let x1, x2 and xn. Okay, these are b, these are IID normal mu sigma square. Okay, so these are IID normal mu sigma, or you can say these are the random sample from the population this. Okay, so now they are IID normal mu sigma square. So these are IID. Okay, these are IID normal mu sigma square x1, x2, xn. So sample of size n from population normal mu sigma square. And now so then the random variable then, or you can say it as statistics t, so that is x bar minus mu upon sigma by root n. First this quantity. So first point I will write this. So see, actually you already know about x bar. In the last class you have seen. So what do you know about x bar? Just I'm recalling you. You know,
Mean, sir. Sample.
yes, right. So x bar will have same mean like sample mean. And what do you know about variance of x bar?
S square.
No. S square is a sample. But suppose sigma square is known. So sigma square is mean of each random variable x1, x2, xn. So what is variance of x bar? X bar is a mean. So what is variance of mean?
Root under S.
No. It will be like, I'm telling you. So when you derive, it will be, you can check your last class, sigma square by n. Similarly, somewhere if you need expectation of s square, so that is sigma square. Variance of s square is 2 sigma 4 by n minus 1. So these are formulas actually you can derive. I think this you may see later on also, I think maybe. So it depends on which chapter you are. Since I have been given in notes, so I'm teaching from that notes provided by your teacher. So I don't know in the book which chapter is this. Okay, so x bar minus mu upon this will have distribution normal 0 1 again. You know why? Because x bar has mean mu variance. So variance sigma square by n. So standard deviation we divide. Okay, so that's why it is sigma upon root n. So this is like that. This is also like that. Okay, so instead of x we have x bar. So corresponding mean and variance I have taken. Corresponding mean and standard deviation I have taken. Okay, second point. So this is T1 suppose, and T2 is x bar minus mu. Now sigma is unknown suppose. So if sigma is unknown, so s square is estimator of sigma square. Okay, x bar is estimator of mu. What I'm telling? X bar is estimator of mu and s square is estimator of sigma square. Okay, so whenever mu is unknown, x bar will be used. Whenever sigma square is unknown, s square will be used, because x square and x bar can be calculated using this sample. That's why. So now this will have whenever sigma is unknown. So whenever sigma is unknown, we will use s. Okay, so this will have distribution t distribution with n minus 1 degree of freedom. Okay, so I think we are running out of time, so I will share actually attendance sheet I didn't bring, so I will share you the link and you can fill this form. So you have just 4-5 minutes to fill this form, so fill quickly this form. Link is in the chat. Okay, so just fill it. So I will continue from here. So this was today's, we discussed only theory. So there are problems based on that. So I think in the next class we may discuss that. So actually T distribution and standard normal both are symmetric about 0. So I may write some point, some remark till you are filling your attendance sheet. So T distribution, so like T I am telling, suppose T distribution, T has distribution, T distribution. This, and suppose X has normal 0 1. So first point is both Z and T are symmetric about 0. So both are symmetric about 0. So both have mean 0, and for large value of n, so n is very large, then T distribution will behave like, so for very large n, okay, very large n, so Tn will behave like normal 0 1, okay. Or you can, in strict probability sense, you can say Tn converges in probability, no, converges in distribution. So converges in distribution to normal 0 1. You can say like this in notation. So Tn will converge in distribution to normal 0 1. Okay. So Tn is a T distribution with a degree of freedom. So approximately n is more than equal to 30 if you take, so they are behaving like same, almost same, okay. So everyone fill the form? Okay, so let me check.
Yes, sir.
21 responses till now, okay. So 27 is done. Okay, then thank you everyone. So we'll continue from here in next class, or whoever will come. We'll continue. Thank you.
Thank you, sir.